Hello, and welcome to the first in a series of many webinars that we're going to do on the Heart Quest. I'd like to say that we just put out the puzzle piece, so please don't forget to read the puzzle piece because it has the what, why, and how of heart rate variability, which the Heart Quest is, and within that, there's a four-part series. So this is the first part, and that's going to give you a really good overview of why this particular Heart Quest system is so special. We're going to be at the Brimhall Homecoming, and we'll be able to test any of the doctors who wish to get tested. So we'll be there on Thursday to do that for those who are interested. With that, I'd like to just go through some of the basics first on heart rate variability. And we have two different components of heart rate variability. We have the time domain and something called spectral analysis. And I just want to quickly review that for those who are not familiar with heart rate variability. These are pretty much traditional heart rate variability analyses that are used. And the first one has to do with something called the time domain. So heart rate variability measures the beat-to-beat changes in the heart rhythm. And if we look here at this EKG that we're going to get when we do our heart rate variability, it's going to show us an EKG. And on that, it'll be like these little R waves, these little where the heart's contracting, the systolic peaks from one to the next. We do 300 of those. It probably takes about 3 to 5 minutes. And what we want to see, just hence the name variability, we want to see that the time between each one varies. That means that that person has a very robust autonomic nervous system which regulates this function. And so it's used in conventional cardiology as a risk predictor to gauge whether someone with a heart condition is likely to have another incident in the next 2 years. We know that it equates to functional illness. Somebody who has lots of functional health issues usually has poor heart rate variability, and they're unable to be able to adapt and to regulate because the autonomic nervous system has to be able to switch back and forth between its two branches, which we'll talk about, the sympathetic, fight or flight, and the parasympathetic. And these branches, hence the name autonomic nervous system. When we talk about autonomic, we're talking about automatic. We don't think about our heart beating, respiration, body temperature. All these things are regulated by the autonomic nervous system, and they have to be seamlessly be able to flow back and forth. And that's why we want to have lots of variability. We don't want a system that's stuck one side of the nervous system or the other. So it's found its way outside cardiology to clinical use as a predictor of overall health conditions. And again, what are we measuring in heart rate variability? We're measuring the ability of the body to teeter-totter back and forth between sympathetic nervous system and parasympathetic nervous system, depending on the needs of the body. And normally in today's society, people are stressed, and a lot of times they're in fight or flight. And if they're in fight or flight, remember that all sorts of physiological changes are going to take place. Heart rate's going to go up. We're going to block areas that aren't necessary for survival, like digestion. It's not a good time to be eating when we're under stress or we're having an argument, because it's going to stimulate the sympathetic nervous system function and inhibit digestion. We're going to need more glucose available into the bloodstream, and we need that to stimulate energy, ATP, so we can have quick energy to survive, to run, to fight, to flee. And we're going to stimulate lots of adrenal stress hormones that we need for survival. And hopefully that the stress is a kind of a short-lived situation, so we can then jump over to the parasympathetic side where things are calming down, where the heart starts to slow down, blood pressure starts to come down. We start to stimulate digestion. This is where we have our healing taking place, where regeneration and healing takes place. And we're going to find out that if we stimulate parasympathetic nervous system with our therapies, that has an incredible ability to reduce systemic inflammation in the body. And that's a whole huge topic right now. We'll kind of just hit on that just a little bit. So heart rate variability reveals the state of the autonomic nervous system, why the autonomic nervous system matters. Well, a normal autonomic nervous system has the ability to up or down regulate sympathetic and parasympathetic tone, depending on the needs of the body. The body can respond to stress as needed, and then can relax and repair itself as appropriate. And that's a nice, healthy autonomic nervous system function. In my office, though, most of the people that come in have really blocked autonomic nervous system regulation, which I can test. When you test somebody and you test the polarity point that Dr. Brimhall has shown you to do, it also a lot of times equates to, and it's blocked, it's not working properly. When you touch the point, it doesn't go weak, where the arm goes weak. A lot of times that is also what we call blocked regulation. The nervous system isn't adapting the way it should. So a compromised autonomic nervous system cannot adjust to changing conditions and has lost its ability to optimally adapt. Thus, the body's response and repair capacities are reduced and long-term health is compromised. So we want to get that autonomic nervous system functioning so it can regulate properly all our organ systems of our body. And again, the people that go from one doctor to the next, they never get well, usually have a compromised autonomic nervous system. What I think is really some incredible stuff has to do with the other component. We talked about the time domain. Now we're talking about the frequency spectral domain. We're talking about where we can actually take within the machine. It does a spectral analysis through a process called fast Fourier transform that breaks down the EKG signal into its individual frequency component bandwidths that correspond to very specific physiologic function. And in this case, this is normal heart rate variability. When you in any heart rate variability, a lot of times you'll see HF. That means high frequency range. This range right here, that has to do with the parasympathetic nervous system. Here's the low frequency range, and that has to do with the sympathetic nervous system. And then we have a very low frequency, and that has to do with the neurohormonal system, which we'll be talking about. That's usually like the hypothalamic pituitary adrenal thyroid axis and its downstream hormones. What is amazing, and we're not going to go into too much depth on that today because it's a whole topic in itself, is we're able to look very specifically at what's going on with Chinese medicine and the meridians and the elements in Chinese medicine. And so we can see within high frequency ranges, we can see the stomach, the spleen, the pericardium, and the triple warmer. We're able to see low frequency ranges with the heart, the small intestine, the gallbladder, the liver, and very low frequencies, the bladder, kidney, lung, and large intestine. And as we get deeper into the Heart Quest and are able to show you more of what this can do and show you and reveal to you, we'll go more into depth on this. So when I was talking to Dr. Brimhall, he was asking how I can use the Heart Quest to be able to examine the specific nutritional items. And in this case, someone asked me to do some research on this mineral formula to see how it would affect heart rate variability. And then what they were wanting to see is if it would increase parasympathetic nervous system activity, which is right over here on this side of the spectrum. So here's your sympathetic and parasympathetic nervous system. And so we're going to show you some of the basics here. This is a baseline. When you do your EKG, this is the first screen that's going to show up for you. And really what we want to look at really is these numbers down here. And what does these numbers mean? Well, this is a baseline, and I'll just explain this. This is cardiovascular adaptation. And that, has to do with, we have 60,000 miles of blood vessels. We have to get the blood to the organs and systems, and especially the brain, so when we stand up, we don't faint. And that's controlled by the autonomic nervous system and its control and regulation in conjunction with baroreceptors in the carotid artery and the aortic artery. And that senses, there's mechanoreceptors in there that sense pressure and send information to the medulla oblongata, to the cardiorespiratory centers of the body, and then in response to that, the cardiorespiratory center, it knows really where what the set point is as far as blood pressure, and it's going to send out information along the autonomic nervous system via the parasympathetic or sympathetic nervous system to regulate, constrict, or dilate to control blood flow. And that's how fast is that happening? How quickly is that able to do that? And that's cardiovascular adaptation. When we talk about the autonomic nervous system regulation, that's the balance between what we just said, the sympathetic nervous system and the parasympathetic nervous system. That controls 90% of your body's organ functions without you thinking about that. Then we have the neurohormonal regulation. Again, that's looking at the control, the hormonal control system via the brain, pituitary, hypothalamic, adrenal or thyroid axes, and how well that's working. And the psycho-emotional is really looking at the electrical activity of the brain. It's not an actual electrical encephalogram. It's a derivative from analyzing heart rate variability, EKG, the electrical, analyzing this signal, and there's a whole mathematical formula that's used to give us an indication of what's going on with alpha, beta, theta, and delta waves in the brain. And actually right here it's very low brain activity. And so when we did this experiment, we gave this particular mineral formula, we got a baseline, we looked at all these numbers, and everything was real low. This particular person actually is an athlete. He's my training partner. He teaches Brazilian Jiu-Jitsu. He competes in submission grappling. He teaches judo, and he personally overtrains all the time. And these numbers are indicative of somebody who's probably very, very overtrained. He's working out all day long, and probably needs a break. But anyway, when we look at this formula we gave him, if you look at autonomic regulation, just go straight down the line here, from July 8th to July 15th, it improved his autonomic regulation. When we go to July 17th, it dropped a little bit. It's kept it up pretty high and pretty much is maintaining very good autonomic nervous system balance. The higher the number here, obviously, the better. And he went from red, which is not good, into the green zone. And when we look at the other indices, cardiovascular adaptation came up as we go from July 8th all the way to July 24th. We were checking him every Thursday to see how the formula was working. This is a great way to test, and we went to his neurohormonal regulation. As you see, that all came up. His psycho-emotional state improved immensely. So that was a really good formula. It worked really well for him. What I suggest is if you're doing a bioenergetic therapy, you're doing like a laser therapy, light therapy, magnetic therapy, any of the bioenergetic therapies, that will change very quickly. But nutritional therapies take time. And that's why, you might want to check if you got somebody on a nutritional program every couple of weeks, it's probably a good time to test to see how those therapies are working. And then on the last treatment on the 31st, the autonomic nervous system shot way up and just shows that he has good regulation between his sympathetic gas pedal and his brakes, the parasympathetic. They're working to improve his overall function and health, which is evident by the total health picture, which is 60%. And that originally was 20%, and it's pretty much balanced at 60%. So that's a pretty good improvement. That's just showing that this particular solution worked. So with that in mind, we went a little further and we looked at some other screens with this gentleman. And we see that his stress index, this is how hard his nervous system has to work to maintain balance. And look at the range. It's 10 to 100. He's 364. He's way over range on July 8th. And this is looking at, here's the sympathetic, the yellow. We call that low frequency sympathetic. Here's his parasympathetic. That's high frequency, only at 6%. And remember, parasympathetic is where regeneration and healing take place, and we're going to find out that it ties in again to increased balance in the anti-inflammatory world where most diseases are taking place. And VLF, we see a lot of VLF when we're talking about, well, let's just say we'll call that aging right now. We don't want to see a lot of this big red here in somebody who's relatively young. And so what we want to see is that come down. And we'll talk more about that. This is the neurohormonal backup system when the autonomic nervous system is getting tired, and it calls in this backup system here, which is not as efficient as the autonomic nervous system. And so what we see here in the first July 8th baseline, his autonomic nervous system balance is way out, 495. This is the range. The SDNN number is a very interesting number. It's a number that is used in most heart rate variability systems to give us an indication, probably the most important indication, of how well the autonomic nervous system is functioning under stress, and it's pretty low. And we look over here at his vital force, and vital force is like how much gas that person has in their tank. It equates to probably chi, and it tells us how much bounce they have in their ability to jockey back and forth within a specific range in nature that has to do with ability to adapt. It's a very important number. And when it's low, you want to be very careful about doing very heavy therapies on somebody because you may crash them. So the vital force is a very important number. Let's just equate that to chi energy. And the range is 50 to 500. He's 30. Okay, so it's pretty low. And so we do the therapy on him, and we decrease the stress index from 364 to 81. So from July 8th to July 15th, that was pretty good change. And you can see that the parasympathetic nervous system was 6%, 17%. Now it's starting to go up. This is what we predicted using this particular therapy, this particular nutrient. And then we can also see that his vital force went from 30 to 50. So it's starting to, at least it's in range. We can see his SDN number is starting to go up from 23.6 to 42.5. We can see that improvement. That's great. As we go further down here, the stress index is still, came up a little bit, but it's still within range. We can see that obviously the red has come way down. The VLF, very low frequency secondary neurohormonal backup system. We can see the autonomic nervous system is starting to increase, which we want to see between the sympathetic here and the parasympathetic. We can see that the autonomic nervous system index balance is much better than the original one. Not as good as here, but the body is changing in a better situation. It's still a little bit over, but much better than the original baseline. And his vital force is still climbing. It's dropped a little bit since then. And then all of a sudden, and that could have to do with what he's doing in his daily life, which is overtraining most of the time. This is helping him actually as an athlete, this formula. And then we go and we look in July 31st, and the vital force just jumps up. The SDNN numbers come up quite a bit more. His vital force is gone from what was the original. The original was 30, now it's 103. So we can say that this formula over time is a very good formula for this particular athlete. What I want to share with you, and there's a lot more screens. We're going to go over them over the next couple of weeks to look at the neurohormonal screen and looking at the brain activity and the meridians. But I just wanted to keep this a little short and just go over a few things with you. There's so much research on heart rate variability at this time. And one of the most important things right now is this thing that's called the cholinergic anti-inflammatory reflex. And it is an amazing system, and it has to do with the parasympathetic nervous system that we're measuring, specifically the vagal nerve of the parasympathetic nervous system, and how it ties in to controlling these these chemicals, these cytokines that, when released in abundance or kind of out of balance, it causes tremendous tissue damage and is related to almost all the inflammatory diseases that we see, from ulcerative colitis to lupus to any of the autoimmune diseases, and even some of the life-threatening situations like sepsis, that is the #1 killer in hospitals today. They actually can stimulate the parasympathetic nervous system electrically, and that has a tremendous, it actually saves lives. It saves lives. And so we don't have to put an electrical device in someone's chest to stimulate the vagal or parasympathetic response. We can do this through all the methods that we're going to learn, as far as using laser, as far as balancing the brain, as far as adjusting the spine, as far as using meridians and acupuncture. All these things, and specifically the breathing program that is in the Heart Rate Variability, the HeartQuest system, which is very specific for stimulating parasympathetic nervous system function to regulate these cytokine reactions. And we have a whole program just on this topic, so I'm just going over it very, very briefly. We know that here's another great article: interval training in elderly men increases both heart rate variability and barrel reflex activity. Basically, that type of activity, that interval training, increases parasympathetic nervous system activity. What patients really care about, since we're talking about aging right now, is that they're younger. That they're younger than their actual age. And this is an example. This is a person that we measured with the HeartQuest, and they're 55 years old, but they're more like they're 52. And patients just love this. The patient is happy when you can do this with them, and they love you. They really do. They go, oh, they're so grateful when you show them that you could drop their age from their actual age and drop their biological age. They just love that. Power spectral analysis of heart rate subjects over 100 years old. Well, on this, they talk about parasympathetic predominance may be the neural autonomic feature that helps to protect ultracentenarians against cardiovascular disease. So again, increasing parasympathetic nervous system function, and we can see that when they talk about power spectral analysis, and we talk about heart rate variability, we're talking about the high frequency range, which is the green on that pie we were looking at. This is another one, relationship of high heart rate variability to healthy longevity, and really the conclusion here is if we could keep the parasympathetic nervous system high, and we can maintain that in the elderly, that represents a prediction of healthy longevity. So again, we want to get in these elderly folks, we definitely want to increase the HF. Same thing. So just to reiterate, in the future, very shortly, I would like to do a webinar just on the cholinergic anti-inflammatory pathway mediated by the vagus nerve. And just to let you know, or most of us have been out of school a while, but the vagus nerve comes off the cranial nerve, off the brainstem here, and innervates, as you can see, lots of different systems in the body. One of the things that it innervates, which is very, very interesting, is there's a specific subset of receptors, nicotinic receptors that are on our macrophage cells, and when we sense in the body, when the parasympathetic nervous system senses tissue damage or a pathogen comes on board and causes damage, it stimulates an afferent signal to the brainstem that reflexes around, and we get an efferent signal that goes to the macrophages, to these special receptors that tones down these cytokines, these chemicals that are released that cause tremendous inflammation and tissue damage in our bodies. And again, in hospitals where somebody has sepsis, that could shut down their organs, where the organs fail and the blood pressure drops and these people can die, they can save them by stimulating this response. And we can talk about how we can do that using natural therapies. And again, here it is. So here's a macrophage. Okay, and what happens is if we have an infection, we have an injury or ischemia, we're going to bring in these macrophages, and they're going to release certain cytokines in the body that could cause inflammation and tissue damage if they're not regulated properly, if they're in abundance. And we have a mechanism to regulate that that's a very, very quick system. So we can sense that in the tissues, our vagus nerve senses that there's a problem, and so it sends its information to the brainstem. So it goes here, it picks up that there's these cytokines, these damaging inflammatory cytokines, tumor necrosis factor, interleukin-1, and it senses that, goes to the brainstem, and then comes back on the motor, on the efferent portion, and it releases acetylcholine to these very specific receptors on this macrophage, and it tones down, it blocks the tumor necrosis factor and interleukin-1 from expressing and reduces inflammation. That's part of the mechanism. We'll go into more depth as we go into other webinars on this. But it's amazing that it's so fast and so efficient, as opposed to the humoral method of dealing with infection, injury, and ischemia through the bloodstream by releasing certain, like glucocorticoids are released into the bloodstream to, just like a steroid, to help reduce and quelch the fire of what's happening at this level. But it's a very slow process. The autonomic nervous system is a very, very quick process, and is going to be very, very important in the future for almost all disease processes. The other thing that's, when we talk about heart rate variability, by the way, when I went and just told you a little bit about this particular system, what they're using, and all these major research projects looking at inflammation and how to use the autonomic nervous system to quench the fire on these cytokine storms that are released. They're using heart rate variability. They're monitoring this with heart rate variability, and they know that with most autoimmune diseases, I have a research paper on rheumatoid arthritis. They have very low parasympathetic nervous system activity. So with all these autoimmune diseases, we want to increase parasympathetic nervous system activity. We'll show you when we go into this at the NIH. They're talking about this, and they're explaining heart rate variability. So this is mainstream. It's not just for us chiropractors and us folks doing alternative medicine. The other big deal for having a heart rate variability technology is the same thing. We want to increase parasympathetic nervous system activity and calm down the system. This is there's some evidence now that angina, unstable angina, myocardial infarction, heart attack is better understood from events happening in the heart muscle, the myocardium, as opposed to events happening in the coronary arteries, the arteries that supply the heart. We're always, most of the therapies are around having to do with the blocked arteries, with doing angioplasty or doing stents to increase blood flow. But there's a whole other theory of what's really happening with these folks that are having heart attacks, and it has to do with decreased tone, again, to the parasympathetic nervous system and increased sympathetic nervous system activity. So a lot of the folks, they'll come in and you'll see that they have tremendous sympathetic nervous system function, the big yellow, the LF that we see when we look at the pie on heart rate variability, and very little parasympathetic nervous system activity in green. And it's not a good thing, because they say the people that have heart attacks, and there's a lot of research on this, they say don't have heart attacks when they have adequate opposition through the parasympathetic nervous system. So when we're stressed, like most people are in today's society, we're going to jump over and to the sympathetic side, and we're going to increase adrenaline. Our myocardial cells break down glucose. You know, we basically, if we're in a stress mode, we're going to have more glycolysis. We're going to produce more sugar, and we're going to be more in aerobic glycolysis. And guess what? We all know that the heart runs better on what? On fats. And so when we're running the heart muscle on aerobic glycolysis, we're going to have more increase in lactic acid in the myocardial cells, more acidosis. And acidosis prevents calcium from entering the cells, and the cells have less ability to contract. An inability to contract localizes edema. This should be swelling, but we got swelling here, excuse me. Dysfunction of the walls of the heart, we get hypokinesis, necrosis of the tissue, we get a heart attack. So the localized tissue edema also alters the hemodynamics of the arteries embedded in that section of the heart, resulting in shear pressure, which causes the unstable plaque to rupture, further block the artery, and worsen the hemodynamics in that area of the heart. Basically, living in our stressful society today creates a lot of imbalances and creates these kind of situations. And so monitoring somebody and looking at their sympathetic, parasympathetic nervous system activity on heart rate variability is really important. And when the person doesn't have a lot of this parasympathetic opposition, they're more prone to having these kind of problems. And so that's another reason why we want to monitor our people with this technology. And we've just given you a little piece of what we're going to be looking at, because again, we haven't looked at a lot of the other windows yet, and that's a whole section within itself. So when we look, and we have this window at this point to look into the body, we're able to see the autonomic nervous system balance, which we talked about today. I just briefly talked about inflammation, cytokine balance via the vagus nerve. We're able to see, we're going to start to show you patterns of health and dysfunction, looking at heart rate variability. We just briefly talked a little bit about neurohormonal regulation. We haven't talked yet about the neurotransmitters that we see here, the mineral balance, the hormonal balance, the vitality. We talked a little bit about that. Very important. If you're working on a detoxification program with your patients and their vitality is very low, I would proceed very gently with them because you can crash them. They don't have the vital force. They don't have enough gas in their tank to deal with a big detox. Chinese medicine, we have a whole section in here on Chinese medicine we'll be covering. And again, we talked a little bit about biological age versus actual age. And I want to thank you for listening today. And this ends this particular segment, and we will continue with more on the next section. Wait.